In this talk, titled Fake Anything, the Art of Deep Learning, I will cover deep generative algorithms in the context of computational creativity. I will talk both from the perspective of a machine learning guy, but also from the perspective of an artist. And I will show examples of how I apply these methods in my practice, how I try to combine AI and art. And I think that some of the things I do also correspond to recent advances in generative deep learning. So it will be a combination of a review and a personal view. And of course, feel free to jump in and ask questions. For the last part, it's a shortened tutorial of, usually I do it for 2 whole hours, just the hands-on tutorial. We will create deepfakes. You will create deepfakes. You do not need any prior knowledge. If you have, you can go further, but you do not need it. And what I'm trying to do there, I'm using open source, but I'm trying to make it more accessible. And from time to time, I'm adding more options. And I have just some new stuff I just added in the last hours. So hopefully you can get to play with it. So let's begin. So if you read the abstract for the talk, apparently Peter did not because he was surprised. You can see that at least half of it was generated by GPT-2, by a language model. So I only wrote the first part, and the bold was completed by a neural network. And actually, I was very happy with this, although it lies. It says that I did a collection of short videos. It's not true, but it did suggest the title for the talk, The Art of Deep Learning, which I was very happy with it, and I adapted it as the subtitle of the talk. So I'm Al Grus. I'm a new media artist. I'm a machine learning researcher and practitioner and teacher. And in my past, I did a PhD in physics. I'm also running an open call newsletter for new media artists. It's oriented for Israelis to make sure that it's relevant for them, but actually also international people find interest in it because it's very extensive review of international opportunities. We are also hosting a mini residency where we try to teach artists from various domains to use data, algorithms, and machine learning in their practice. And maybe I'll show some examples in the end. And the day before Corona, I was practicing digital nomadcy, but of course today it's less relevant. Hopefully we can go back to it soon. At the time, I also had a startup. It failed. I'm not doing this anymore, but at the time, I think we were the first to demonstrate a live demo, taking a bitmap floor plan, using deep learning to interpret it and creating a 3D model that the user can walk inside, either in the browser or in VR. And all of this happened in like 40 seconds or so. But I'm not doing this anymore, just mention it because this group is on 3D stuff. And I'm going to speak from a very personal view. So just to give you some background, on the artistic side, my talent is very limited. I can write words, write and read code, and I have many ideas. I cannot do many things. I do not know how to write or play music, not to draw or paint, as will be evident later. And also sometimes I have a writer's block and I cannot even write. But I can write code, and my code can maybe suggest alternatives, suggest completions, help me generate media, empower me to manipulate media or to perform it media. But it doesn't yet replace my concepts. It doesn't replace my artistic process. I still write my machine learning by myself, and we'll speak extensively about about poetic choices, which I still make by myself. So we'll talk about neural networks. I assume all of you know about it. If someone doesn't, it's an abstraction of what we think happens in the brains, where cells emit electrical signals. They are connected one another in a large network, and when you learn new concepts, these connections form, and this is called a neural network. The algorithm, artificial neural network, is an abstraction of this. And we are talking today about deep neural networks, which are neural networks with many layer and more complex architectures. And if you don't know about this, it's not so important for the talk. I will mainly talk about this kind of machine that you see in the slide, a generative neural network. And in general, it's composed of two parts, an encoder and a decoder. It has input, which can be one of these various mediums, and it has a different output of one of these other mediums. Now, the way that it works, that this machine gets an input, say a text, it encodes it into some dense vector code, for example, say a computer representation of the media, and hopefully of the semantics, of the essence of the media in some way. And then the decoder can transform this computer representation back into one of these human consumable medias. So for example, maybe you would input text in English and translate it into Hebrew. Maybe you would put in an image and get a caption of what is in this image. Maybe you would put in a caption and the decoder will draw an image for you. And in general, you can imagine all of these kinds of manipulation. Now, you can only use the decoder, or you can put in some random noise and look at it as a generator that just creates unconditional output. But in general, I think we should think about it as a transformer that can take various input, process them, and put out various output. So this is the generative neural network, but it doesn't do only generation, but in general, manipulation or translation, if you wish. This is machine learning, so we train these networks by giving them examples, in this case, input and corresponding required outputs. And it is interesting to discuss because these methods give nowadays state-of-the-art results in image processing, language, and many other domains. Let me skip some of the historical and technical background. I will mention object detection in later slides. I hope most of you know it. Essentially, given an image, a neural network can detect the location of various objects and the category of the object. Okay, but I want to focus on generative applications of neural networks. And I think it's good to start from this simple example. So in this example, we're doing automatic colorization. We have data, it's called ground truth, it's color images, and we can simply transform them to black and white images. Now we have the input and the required output, which is the ground truth. And we teach a model, we train a neural network, given a black and white input, to output a colorized image, which in some sense is similar to the real color image. Once I'm finished training this model, what is it useful for? Now I can apply it to black and white images or videos from the 40s, or in Israel from the 50s, and get the color version of them. And hopefully similar to the natural colors of the original footage, original nature. So it turns out that a similar method And you can think about it as having some kind of noisy channel, and you want to inverse cancel the effect of the noise. So it turns out that you can use a similar method to solve many problems as such. And in the first example, you can take an image and add some artificial noise and learn the transformation to denoise it, to remove this speckle noise. In the second example, which is more interesting, you can learn how to do image enhancement, specifically super resolution. How would you go about it? You would take high resolution images, you would artificially lower the resolution, and you will learn a transformation given a low resolution image to recreate the high resolution image. And for example, you can see that some of them are able to capture the separation to 2 yellow lines and 4 black lines, and some other algorithms are not able to do so. And this was science fiction until some years ago, when we seen it in Blade Runner or CSI. There was no such technology, but today we actually have it. And the last example here, Inpainting, you take an image, you take out a specified part of it, this middle chunk, and the algorithm learns, given the context, how to complete, how to inpaint the missing parts. Now, as I went through these examples, they became less and less trivial and more generative, or if you want, imaginative, or even hallucinogenic. So the algorithm here is hallucinating, is generating something that was not there before. Hopefully, it's seen enough relevant images to learn the correspondence between the context and the missing part to give an appropriate completion. This is a very useful example from Photoshop. This guy has a plaster on his nose, and so they wanted to remove it. And on the right, you can see the previous algorithm content-aware fill in Photoshop, and which was developed in Israel, and it actually added a third eye. Not very good in this case. And the neural, like deep field version, has a very good completion of the missing part. This is an easy problem, but you can also see more complex examples.
Eyal, we have a question. Yeah. Akshay, I hope I pronounced it right, asked, what can we add in these algos such that they become generalizable?
So this is a big question, and I'm not sure if I have a general answer for it, but if you want to be more specific, you can try. But in general, it's a matter of data. It's a matter of regularization. It's a matter of adapting the inference data to have a similar distribution to the training data. So there are various ways to address it. It's a little bit much too general. If you have a specific example, I can try to address it later, or specific concern. So let me go more in the creative or hallucinogenic direction. In this blog post from a few years ago from Google, they came with a deep dream algorithm or experiment. So they took this image of clouds and they put it in an image detector. Now the image detector, like we've seen before, an object detector, it responds to an input image. I think someone's mic is open. Please mute. So now there is no animal in the clouds, but there is a response from from the detector, from some parts of the detector, from the neurons that are adapt to find animals or animal parts. And they made an interesting manipulation. They changed the pixel in the input image to increase, to emphasize the reaction of the neurons of the object detector. And they did so iteratively until they got this manipulated image. But it's very interesting because these are very specific manipulation that deceive, if you wish, the object detectors to think it's actually seeing these animals. And they got all these funny animal hybrids. And I think this is very interesting. We as human, we have this feature called peridiola, where we can find patterns, even if they do not exist, specifically visual patterns. When I look in the cloud, sometimes I see animals or dragons. So I think it's interesting to compare. And it also reminded me of the film Short Circuits. Let me show you a snippet. We have now robots or software that can see animals, dragons in the clouds, and read Rorschach stains. And of course, the internet was very happy with this, and you can find all these applications and demonstrations. And here you can see this walk in the forest with these generated animals, and this scene from Fear and Loathing in Las Vegas, very appropriate to have this effect here. And it works with natural images, not so much with text. So here I've written in Hebrew, I love you, with chocolate bars, and many years ago, and created this effect on the text. So this probably does not have a real use. Maybe it brought on different things regarding adversarial examples. But I want to talk about a more useful algorithm called style transfer. And here again, it relies on the notion that an object detector should be able to discern between the style and the content, because sometimes you don't care about the color of the object, just on the shape of the object, for example. And here they were able to apply this in order to take a style image, say this a painting by Picasso, and this content image, say the Gandalf the Wizard, and apply the style and the content and get Gandalf in the style of Picasso or Mona Lisa in various styles. And of course, today this is available in applications and web interfaces. And you can also do it for video in this nice homage to Odyssey 2001, which had a 50-year anniversary recently. They made it in the style of Picasso. And I was also actually able in some event to put on AR glasses showing like 3D reality with this kind of psychedelic style. And of course, so I said this is useful, and here you can see some more applications, maybe relevant for the creative industry. So here you can see a black and white drawing and a color image, and here you can see the content of the first with the style of the second, and this is vice versa. On the bottom, you can see a church, which I want to preserve the geometry of, and another one of which I want to take the style, and this is a combination, the geometry of the first with the style of the second. And going back to the more creative or artistic usage, so here you can see a city in the form of electrical circuits, or sausages in the form of fish. And I chose these examples because I like them. I thought they were creative. And you know, sometimes when I talk about this in the context of art, I get this criticism. People ask, but is this art, or isn't this just a filter I can apply in my app? Or why do you call this art? And this opens a very interesting discussion that I want to dive into now and connect it to contemporary deep learning in a few minutes. So I got this high school thesis from '86 from a guy I knew at the time at the university.
Hey, Al, I'm sorry I'm interrupting you. I just wanted to say the previous time. Tichon the same. This was my high school. I studied there like 15 years ago, maybe a bit more now.
Okay, so now we know how old you are. So I translated some parts to English. So this is about computational poetry. At the time, probably he used like a simple Markov model. And he says about this generative poetry, selecting from the various results of a generative process is an act of art, no less than creating. This is a poem. The Google Translate is very bad, forgive me for it, but it's actually a beautiful poem. Maybe you can allow me to read a short part in Hebrew. חבל שלא התאבלתי על מריאנה חכמה בסתיו. אין ורד בלי שמש, אין עץ בלי דרך. חבל שלא התאבלתי על מריאנה חכמה בסתיו. This is poem number 521 from the thesis. There are many more. And he compares this to the act of photography. And you know that the photographer, she does not paint nature, she does not sculpture nature, she does not build the buildings or create the humans. She chooses the frame, she chooses when to take the photograph, probably doing many other things that I know nothing about. But essentially, it's an act of selecting, of making a choice. And the claim here that this choice is an artistic choice, it's a poetic choice. And he goes on and says that in generative art, the curator, the one that makes the choice, is the artist. The act of selection is the poetic moment. And he asks later, could a computer do curation? This seems far-fetched. If it comes true, we must name the computer poet, which we will soon do. But just one more comment about style transfer. This is an experiment I did with a colleague of mine, Batgirl. So you see a photograph that I took of her on the right. And on the second column, you see Matisse' famous painting, called Green Stripe, or Madame Matisse. On the third column, we took the photograph that I did and put it into an app, DeepArt.io. Got this very good color representation. And on the last column, Batgirl, which is an artist, she took this photograph and she painted on it. Now, she's not a painter, but she knows a lot about art, and apparently more than the algorithm, because this green stripe and this neck part is a very important characteristic, I don't know how to say it, of Matisse's image. And the algorithm completely missed it. And she actually put extra emphasis on it. So the very high level of understanding the artistic style of the photo, there is still some way to go. Okay, probably all of you know these guys because they tend to appear in any presentation on generative algorithms and deep learning, at least in the past 2 years. In this work by NVIDIA, they can create an infinite number of new faces, and actually today even you can get better results. And this was used, this was done using an algorithm called Generative Adversarial Network, or GAN, from 2014. But let's jump a few years ahead to get better output. Maybe a lot of you already know this, but bear with me, we will go further in a second. There is the generator, the same network that we talked about until now, creating these computer-generated images, in this case of the faces of celebrities. But we also have a second network, in this case called the discriminator, and I like to call them the creator network and the curator network, or in Hebrew, reshet yotzeret, reshet otzeret. The goal of the discriminator is to discern if the image is fake, computer generated, I mean, or real. And we train both networks together. And the generator will try to deceive the discriminator, and the discriminator will let the generator know via the loss if it was successful or not. And they play this kind of game. And when we go on and train, because the generator tries to deceive the other network and they both get better, in the end, usually we throw away the discriminator, we don't need it anymore, and we are left with the generator that produces these state-of-the-art photorealistic, in this case, images. This is the GAN algorithm, Generative Adversarial Network. Now, this was a non-conditional example, and the conditional can be much more interesting. So in this case, so before we just generated faces of celebrities because that was the data set. In this case, there is also an input image, and the output is conditioned on the input. In this case, taking the profile, the side view, and recreating the frontal view, while trying to preserve the identity or the visual identity of the person. And actually the authors here asking the abstract to guess which column is the real one and which is the generated one. So, so more generally, we can speak indeed about, in the case of images, about image-to-image translation, and this algorithm called pix-to-pix was revolutionary at the time, being able to train it to do various tasks from starting from, say, black and white to color, but also going from these simplistic category maps and create photorealistic images, doing, say, aerial image to map, or even vice versa, doing contours to bags, doing day to night or night to day. Now, to train this algorithm, I need the pairs. In my training set, sometimes it's easy to create, like the black and white, if I have the color. Sometimes it's more difficult. If I want to do day to night, I need to leave the camera for 12 hours to take the image. We will come back to this in a second, but let's speak about this contour problem. Oh, by the way, there's an online demo you can play with for a lot of things that I will show, and we will also share some other links later that you can play with by yourselves. So let's remind how this works again. We have the data, it's called ground truth. From this, we can make contours. So you can use your favorite contour edge detection algorithm. Actually, they used deep networks. Or you can use Photoshop. And now you want to train a model given the contour input to output something that is similar in some sense to the ground truth. And you can see that the output here is indeed images which look photorealistic, which are diverse, which are interesting, which are creative. Maybe they can give new ideas for designers for bags or shoes. But mind you, we needed to create these kinds of pairs to train the algorithm in a supervised fashion. How does it work? Again, it's a GAN. So in this case, it's a conditional GAN. So say for the task, a map to aerial image. So the map goes in the generator or the transformer translates it into an image. And now we have this couple, this input and this fake output, and we put this pair into the discriminator. And it should say if this pair is authentic or not. In this case, it is not authentic. But we also have the data. We have the true correspondent map and the aerial image, and this is an authentic pair. And we train, similar to the GAN, to where the discriminator needs to guess if it's real or fake, and of course an educated guess, and give back a signal to the generator. Now let's go back and deal with the supervised issue. So in this next revolutionary algorithm, and actually there are several very similar solutions in the same time, most notably CycleGAN and DiscoGAN, they did this in an unpaired fashion. And indeed, they show examples of doing summer to winter without leaving the camera for 6 months to get this pair. And then probably the most famous example is horses to zebra, or in this glitch, Putin to zebra. And to do this, they just took a data set of horses and a completely unrelated data set of zebras without any correspondence between specific images. So there is no pose of a zebra standing in the same pose of a horse. How does it work? So they use a cycle consistency condition where, so for example, in this case, doing blonde to brunette or doing vice versa, brunette to blonde, it works like this. They have two generators. So they have the blonde to brunette generator, and they have another one, brunette to blonde. And if they chain them, so blonde goes to brunette, and then brunette goes back to blonde, and they put a cycle consistency condition that this recreation will be similar to the input. Now, this blonde is a real image, and this from the vice versa process, brunette to brunette. So this blonde is a generated one. And now they can ask the discriminator to discern between real blondes and computer-generated blondes. So combining the cycle consistency with the GAN architecture, they were able to do this unsupervised interesting transformation. Also, it can work with a very small data sets. So we did this experiment, or art project a few years ago, to me and Eran Adas, inspired by Archimboldo, by the Israeli Hanoch Piven. We wanted to create vegetable faces. And this is now in a museum in Germany, and you can see it has two parts. So this is a real-time painter, AI painter or generator, specifically the generator network, that it takes, opens the camera and gives a transformation of your image into a vegetable face in real time. Now, this was also not trivial at the time because there are some geometric manipulation of the face parts, and it doesn't work with vanilla CycleGAN. We had to invent some modifications of the algorithm based on other work like Distance GAN by Sagi Ben-Haim and Lior Wolf. In later years, there came to be more solutions to do this geometric manipulation, but this is at the time it was one of the first examples doing so that I'm aware of. And maybe this is more interesting, the other part. So I said that usually we throw away the discriminator. Here we kept it and also use it in inference. It looks on the output of the painter, and if it deems it's a good enough vegetable face, if it's a convincing vegetable face, it shows it in the gallery in the museum, and this is some stupid curatic text that we write about it. And this work is called the electronic curator. And this is the point. If you remember, I started this discussion by saying that in generative art, the role of the artist is the selection, the curation. And we talked about it that maybe if the computer can do it, we should call it the poet or the artist. But it turns out that in the most popular and successful algorithm, generative algorithm of the last years, the generative adversarial network, it actually has a small curator inside. And if we take out this curator, what we're saying here that today we cannot only have AI painter, maybe we can also have an AI curator. And we trained this with a very small data set that I found in Google doing image search for vegetable faces.
Hey, Alan, this was real-time inference running on your laptop, right? Nothing special.
This is on a strong enough GPU, but so again, the geometric transformation was an issue at the time. There's some new works from the last year. I didn't try them out yet, not all of them, but it's not a trivial task. In this experiment, we tried to make like a hand puppet theater, changing the hand into these kinds of birds. Sometimes it works nice, sometimes it gives funny stuff. But probably today we can make it work better. And so I'm reviewing here my work with correspondence to the developments in the field, and I'm going forward in the years. And 2 years ago came out BigGAN. BigGAN is a generative a deep network, and it can create these photorealistic images. All these images are created by the network from one of the 1,000 categories of ImageNet. If you don't know what ImageNet is, then say mushroom dogs and other dogs and soap bubbles and other stuff. And this looks very, very convincing. Photorealistic. As an artist, I don't find it so much interesting. On the other hand, this is Mario Kligman, one of the most famous digital artists nowadays. And he, on his Twitter account, put these images that he got also from BigGAN, which are not photorealistic. But I think it's very interesting how he randomly went around in the latent space of BigGAN. We'll mention it in a second, and created these images. And he didn't have much control on the content, but he could tell a story with them that he walked in the desert and met this bug, and he took it to this inscription and to this spaceship and the aliens and so on. And I really like the way that he used it to tell a story, but I wanted to control the content. And I had a problem. BigGAN is a decoder. Only a decoder, and it's very expensive and hard to train. If you remember, we spoke about encoder-decoders, but BigGAN is only a decoder. So I cannot condition it on a certain input. I can give it a code, a computer representation, but for this computer representation, for a given computer representation, until I put it in, I'm not sure what would be the output. And I wanted to solve the problem of inverse rendering. So for a given required desired output, I wanted to figure out what would be the code to put in to get my desired output. And then I can do some manipulation on it. So people try to solve it. Again, maybe today it's easier. At the time, the results were not so good. And I took my attempt and I used a common method called evolutionary search, just to try many combinations and combine them in a smart way. And I got nice results I want to show you. So I'll show you 3 images. The first one is this dog. It's actually computer generated. Let's start with that. So I'm showing you here just the search process, the optimization process of trying to find the code that produces a desired image without inputting this image, just using it as a target for the evaluation. So I think you've seen that the production is almost perfect. Now this is a real photograph. This is based on a real photograph of my dog, Alpha, I took at the time. And now you will be able to see that the reconstruction is also very good. Both the semantics and the style, as we will see in a second, is very, very similar, okay? Now, the third example is the most interesting. And here the recreation will not be so good, but I think it's very interesting because it captures the semantics of the image. And here we're trying to recreate Savion, a colleague, performer, friend of mine, wearing some puffy wings. And there are no images like this in ImageNet. This was the original target. And you can see the reproduction is by no means exact. Even the pose is opposite. But it caught something of the semantics of the image. And this was interesting for me for making the next project, which is an artwork called WonderGAN. And in WonderGAN, I have this objective, this flashing memory of mine. And now I'm applying this process to make BigGAN recreate my image. Using this in real time, this process of evolutionary search, and making and showing the best attempts. And I think it makes an illusion of some kind of visual journey. And if you wait long enough, here there are some skips in this video, but essentially it works in real time. And if you wait long enough, you get something of the general likeliness of my desired image, so I can control the narrative. But also it's interactive. So you can actually go in when it's working and press one of these quadrants, and now it will forget the original target and it will focus on this quadrant and try to recreate that. So I think this creates something of an effect that you may recall from dreaming, where you see something in the edge of your vision and you think about it, you zoom in on it, and it develops into something completely new. So if you want, here you can, in this journey, in this hallucination of the neural network, you can go in and navigate inside. Or you can just let it be and allow it to do this journey to recreate the original memory that I put in. So, so this is a WonderGAN. And moving on, so I'm going back and forth between like more artistic uses and and some applications that can be more relevant to the creative industry. So, but this is like all the stuff. Let's jump a few years to this work by NVIDIA. Also, there's an online web app that you can play with. So I'm not a great painter. This is my skill on the left, my painting skill. And with one click, yeah, is there a question?
Yeah, we have a question here from Shai. Do you calculate the loss of the output and your target image, and then calculate the gradients with respect to random noise and updating according to the gradient? You can see it on the chat, maybe it's easier.
Yeah, so in this case, I'm not training and I'm not doing gradient descent. It didn't work for me. And I'm actually using a different optimization, a global optimization method, specifically CMAES, which is a form of evolutionary search. So there's no, so I'm just optimizing the embedding, the representation, what I call the computer code, the list of numbers that put in the model will generate the output. So I'm not doing any training, I'm just manipulating, trying various inputs and finding the optimal inputs. And I'm doing it in a non-differentiable algorithm.
There's another question here by Rachel. I'm not sure I understood that.
Yeah, okay.
Yeah, no, but we have an international audience. By the way, it's a good time to mention again, everybody, feel free to say it yourself. I can read it, but you know, if you say it, you get a chance to ask follow-up questions also and everything. Just feel comfortable saying it yourself. So Rachel asks, I'm not sure I understood the process of searching in the latent space and recreate an image from it. Can you explain further?
Yeah, of course. So I didn't go into the specifics, and I'm not sure if we have like a homogeneous technical background of the people. If you do not have a technical background, I assume you do, but for those who do not have, I like to make the metaphor of having a very talented painter, but the painter is blind, unfortunately, and maybe also deaf. So I cannot tell him what I want, I cannot show him what I want, but he's very talented. He creates many copies, and I just tap his shoulder to indicate if it's a good or bad outcome. And he takes the best ones and he tries again, he recombines them until he gets the perfect result. So this is on the layman term. On a more technical term, so what I'm doing in this kind of evolutionary search and similar to genetic algorithms, I'm trying many different inputs, and I'm combining them in an educated way in order to try to ascend on my loss that I did not define, but a combination of various local and global and computer vision and model-based losses until I get something which is close enough, or until I find my optimum, which hopefully is close to the global optimum. So, but I didn't go into the specifics of the method. If you wish, we can take it further later. Okay. So, so in this example, I only painted this kind of very crude image, and with one click, the NVIDIA SPADE turned it for me into this, it's not maybe completely photorealistic, maybe the trunk is not so good, but you can see actually the water is very nice, and also the reflection of the tree in the water is very nice. And so for today, for natural images, for face images, there can be very, very good results, and you can, again, play with this by yourself. Going back to the conditional generative tasks, in this case, what they did in this work, SPADE from the end of 2016, excuse me, they're taking a text, a small caption, and they're generating an image, but you're trying to generate the image that is described in this text. So for example, here they describe this bird with a yellow belly and a gray, I don't know, beak. And they try to paint this specific description. So this is not retrieval, it is generation. And this work was groundbreaking because people were working on this for some years before, and people working on this thought it will take maybe one more year to do, and they were surprised that these results were achieved at the time. Now, probably you know the story of AlphaGo. People say that it came earlier than anticipated, maybe by a decade. So this is a smaller example of this, but I think it's very interesting when the researchers working on the field are surprised by the acceleration of their own field. So they did these birds and flowers, and later came other versions like these AttnGAN that can do also other kinds of objects. And you probably know about cherry picking. So of course you know about cherry picking because we spoke before about curation. So cherry picking is like picking the best results. You may also know it from your Tinder account, where you put your best photos, and also in the papers, people tend to put the best photos, something they also put the failures, but not always. So I wanted to play with this and get some real experience, real results. So I put these sentences, I got these interesting results, like so for the sunset, I got this floating island, and so on, some other examples, some out of data set examples. So this is not good enough for industry, but as you may guess, it's damn good enough for poetry. So in this hackathon I did with Vered Heruti and Elad Sapirstein, we created pictures of job codes and synthesis, a quote from David Bowie, and it's I'll let it speak for itself.
Dove, a deer, a female deer. Red.
Sorry for this.
A drop from golden sun.
ایمان بیاوریم به ویرانه‌های باغ تخیل.
ואז גם אני יכול לנוע מהר מהאור.
물끄러미 바라보다 고운 난초를 건네는다.
به ابرها که فکرهای طویلم بودند.
성낸 까마귀들이 너의 새하얀 빛을 취샘할까 두렵구나.
So I see in the video there is a delay, but this works in real time, and it's a poetry, spoken poetry to visual poetry machine. We did it in a 30-hour hackathon. We actually just used 3 models ready-made and fused them together. We used a Google speech-to-text, and then we used Google Translate if it's not in English. And then we used AttnGAN, which takes a small text, a short text in English, and paints what is described in this sentence. And we attempted here to create this a real-time visual generative poetry machine, maybe having some kind of a synesthetic quality, and maybe also giving a more universal poetic experience, because I didn't understand the Korean, but probably you could see the colorful flower she was talking about. So this was a very fun artistic project. And going forward, these generative algorithms, they get better and better and allow also more control. So in this example by Hong et al., you can also change the background and change the type of animal or the relation of the action of they do with the animal, the number of animals, the location, the size, and so on. And it gets better and better, but still when you have a complex scene, it's not, maybe it's not good enough. It's not photorealistic yet. This was a problem because Eran Adas and myself, we wanted to do this work for a long time called Alt Reality Cam. And generative didn't work for us. So we went back to old school and we went back to doing search and retrieval. But we did a very simple trick that I'm not sure why isn't done more often. So today we have all these large data sets. We have these very good pre-trained object detectors. We even have bounding box annotations for a lot of the data, but even if you don't, you can just run your object detector. And now what we do, we take this input query image, we find the layout, the bounding boxes, and the categories, and we go over a very large pre-annotated or pre-labeled data set, and we look for a corresponding layout of objects. And another allowance we make here is we respect the semantic hierarchy of the labels. So a rifle is a type of a weapon, a pistol is a similar type of weapon, a helmet can also go into a hat. And you can see that just using this kind of spatial layout and semantic hierarchy, we can get very nice retrieval results, probably more controllable than what you can get or what you could get at the time from, say, Google reverse image search. So this is just the technology we needed. You can play with it, by the way, on this Twitter account. And now we went on to make the artwork, which was in Petah Tikva Museum until recently. So the idea is to create a filter, a very high-level semantic filter, maybe a philosophical, political, or emotional one. So compare, for example, to the Instagram filters, changing the style of the image. Sometimes maybe they can also do something with the semantics, like the gender one. But here we're completely taking the image and retrieving an image from a completely different image, from a different conceptual world, but having something similar in its layout, maybe in the interaction. So you see in the gender example, of course, the cats turn into girls. And in the romantic filter, the cats turn into teddy bears. We're doing some, I'll talk about it later, about representation of text. So we're doing this smart manipulation of the labels of the concepts and retrieving a corresponding image with these very high-level semantic features and this simplistic spatial semantic retrieval technology. So the dogs here will become, in these cases, either girls or fighters or these hedgehogs, which are not very frightening, but they are supposed to be. Any new questions? Okay. So we discussed mostly images. For video, it's maybe more difficult. It is more difficult. If you think about the corresponding tasks, either taking an image and completing it into a video, or taking a section of a video and continuing it, or maybe even taking a text snippet and creating a video out of it, we are still not there. I guess I will be surprised in a very short time, but we're still not there. Last time I checked, maybe the best example, for example, from text to video was actually for animation. They did it for The Simpsons. So they give this description and they create this very short scene from The Simpsons. It's a very complex algorithm. Hopefully, one day someone will do it for Rick and Morty. but for video, we can do other stuff. We can do, and we will discuss this in more length later in the talk, but you have this like audio video correspondence. So it's a paired, there is a pairing between audio and video. Many works go from video to audio, from audio to video. And we will also see works going from a video to video and using the input video to control or be manipulated into an output video. And let me hold this for the end because it's related to the topic of the tutorial and deepfakes and avatars. But before that, I have some more stuff to discuss. And I want to discuss now text. One of the basic important algorithms for text is called word-to-vec or word embeddings. And in this case, and it's a good time to mention again the importance of the learned embedding or learned representation or learned computer code that embodies, if you wish, the essence or the semantics of the media that we are trying to model. So in this case, they took a corpora of, is there a question?
Yes, yeah, there's a question. What algo you recommend for it?
So actually, I'm not an expert. I'm doing some stuff on video in the medical domain, but I'm not an expert on activity recognition. But probably you can find these like GitHub awesome action recognition. And if you need, I can take it with you offline and help you search. So,
actually, you also can raise this question on the Discord. I think some of the people there are working with medical machine learning. So maybe they will be able to answer this. If you're on the Discord, I don't know. If you're not, you can just ask me, I'll send you a link.
Okay. So in this case, they take a corpora of texts, and just by considering the relation, the context of words, the words that neighbor other words, and solving this auxiliary task of completing missing words, I'm not going into it, but they were able to learn an embedding, a representation, a vector, or if you wish, a list of numbers for each word. Now, this list of numbers, this vector turns out to be very interesting because they can make mathematical operation and manipulation on it in a semantically relevant way. So in this example, in word-to-vec, it's actually 300-dimensional, but it's very hard to imagine. So I'm just showing here 2 dimensions, x and y, and put the word on the map depending on its x and y coordinates. Now, all of us know to do algebra in our head on words, correct? If I ask you what is a king that is taking out his manhood and putting in womanhood. So I want to subtract the boy from the king and put in the girl. Can someone help me? What is a king that is not a boy but a girl?
Queen.
A queen.
Yes, it's a queen, a very canonical example. It's a queen. And it turns out that this is semantically. It turns out, very interesting, that also in the embedding space, I can do this kind of vector algebra. And taking this vector, this arrow from man to woman, if I bring it to king, I will find here, probably one of the words would be queen. And this is learned in a self-supervised fashion. So it turned out that this is an easy way to get these interesting semantic or syntactic also analogies, like France to Paris is like Italy to Rome, or Microsoft to Windows is like Google to Android, in a self-supervised fashion. So this is very useful, and it's a building block in many later algorithms. This is an artwork of mine where I put this stuff into, I did it again. I put it into like a 3D cloud of words. Similar concepts are grouped in adjacent spatial locations, and I'm using both my voice, that it recognizes the words, to jump to different parts of the cloud, and then I'm using a Kinect to go around with my hand, and I think about it like an instrument. I'm like playing the words and doing this kind of associative writing based on this word-to-vec cloud layout. Now, this is also a good opportunity to discuss something about a bias in machine learning, which was just discussed heatedly in the last 2 days, as it is from time to time. So we say that a man to a woman is like a king to a queen. Turns out that it's also like, say, atheist to feminist. If a man is a surgeon, so what is a medical profession for a woman? Turns out it's a nurse. Men are architects and women are interior designers. Men watch Simpsons and women watch Oprah. Men have, unfortunately, strokes and women, unfortunately, have breast cancer, and so on. So this is bias, and usually it comes, we think it comes from bias in the data, from the historical data sets. Note that sometimes this bias can be relevant. So for example, nowadays, we don't want to associate doctor with man and nurse with woman. But maybe if you're looking at World War II from a historical perspective, you do want to retain the fact that most of the people that fought in the war were men, or that most people that died in the concentration camp, or at least a large significant part of them were Jewish people. So maybe the bias is relevant from a historical or statistical point of view, but maybe if it's something developed for a current use, maybe it's not relevant. So in this very interesting paper called GradCam, which actually discusses the algorithm to do this kind of interpretation and show us this heat map to help explain, and interpretability and explainability, as you will see, is also a very important domain in this context. So it shows us not only the prediction of the algorithm, trying to guess if it's a nurse or a doctor, but also why it taught, why it took this decision. It highlights the area it focused on in the image. So in this first case, we have a nurse, and the algorithm predicted correctly it's a nurse, but for the wrong reasons. It looked on the hairstyle, which is the hairstyle of a woman. And you know, the original data set was like 80% doctors were men and 90% nurses were women. So what they did, they created a gender balanced data set. And now on the balanced data set, the algorithm learned to correctly predict it's a nurse, not because of the hair. It ignored the hair just because of the uniform. And in the second example, so we want the algorithm to take the right decision for the right reasons. In the second example, we have this doctor, lady, woman doctor. Originally, the algorithm thought she is a nurse. Why? Because she has hair of a woman. And in the balanced data set, now it knows correctly it's a doctor because she has a stethoscope. And yesterday, or the day before yesterday, there was this heated debate using a face Depixelizer. So this is a generative algorithm taking in a pixelized image and recreating a photorealistic image. And of course, you know that when we are missing information with this noisy channel, the algorithm uses its knowledge of a context, in this case, actually of the way natural faces look, based on a database, in this case, a database of celebrities, to recreate the original image. Probably, there's a heated debate, but probably this database, most celebrities were white, and here pixelated Obama became whiter, and people were debating with this. I made a funny experiment. I took this white, completely white rectangle or square and got this image. When I tried it with the black square, I got nothing, just a completely black image. I'm not sure if this is because of bias or because of the way that the images are normalized, but I thought it was a funny experiment, and you can also play with it yourself with this code here. Okay, so this was something about bias. But going back to word2vec and words, I'm doing various experiments with text. So some of them are in Hebrew. I'll spare you. These. And let's jump to sentence representation. Like you can represent words. You are also able to represent sentences, also capturing something of the semantics with the layout in embedding space. So in this case, all these sentences are talking about John liking Mary, and this is vice versa, Mary likes John. So there is some natural clustering here in this example. And once you also have a generative algorithm for sentences, and we will maybe discuss an example in a second, you can do, and this work by Bauman from some 5 years ago, try to do interpolation. So between one sentence and the final sentence, and generate sentences in between, hopefully in a semantic way. And I think the result has some kind of artistic quality. So let me read one for you. The bottom one. There is no one else in the world. There is no one else in sight. They were the only ones who mattered. They were the only ones left. He had to be with me. She had to be with him. I had to do this. I wanted to kill him. I started to cry. I turned to him. So I like the result. I had to do it in Hebrew, so I created this web interface, and I call it a Shir Retzef. The idea is you take the first and last sentence from a poem, in this case, the Israeli national anthem, and create sentences in between. The result here is not so much semantic. There is still work to do on this. And I found this interesting slide from this unknown talk by Bojar, and he suggests many ways that you could go about, and we still do not have this technology yet, to do this kind of interpolation, going in embedding space and controlling things like the sentiment, the politeness, the tense, the modality, the registered, slang or formal language, and so on. And we do not have this yet. I did try to work on this stuff. I was in a residency in Jeju Island by the Korean TensorFlow user group some years ago, and I tried to do it with transformers. It never worked so well, but I did get a result which I was very happy with, because I only found one other reference in literature. I did not publish my results, but what I'm discussing here, and also discussed in this work by a guy called GAN, no relation to the algorithm, GAN et al., doing algebra on sentences, like we did on words in word2vec. So in this case, he had thought he was going crazy, minus I felt like I was going crazy, plus I felt like to say the right thing. And so we want him, instead of going crazy, we want him to say the right thing. And GAN got this result. He had thought to say the right thing, and I got these also very viable results. He had thought he had to say the right thing, or he had to say he thought the right thing. So these are initial results, but very interesting that we can do algebra and analogies on the sentence embedding representation and get a semantically relevant results. Probably you heard about GPT-2. It's a language model. It predicts the next token, the next character, or next word, given a sequence of previous characters. And this came out in the last year. It gets better and better each time. Now we already have GPT-3, which is very, very costly and time-consuming to train. You probably cannot do it yourself on a relevantly large data set, but we have some pre-trained models. And you have this online interface, talk to the transformer and others that you can play with. And I put in this initial seed, the beginning of the text. President Trump has just landed in Israel. And I got this continuation by the algorithm in red. And it says, it continues like this. This is the moment the world woke to Trump's America First policy. There's no secret in Israel and the Jewish media that the US is one of the biggest buyers of Israeli military aid. Just a couple of days ago, the Israeli press had an interview with top military officer whose son was killed by a shell fired from Gaza. The head of Israeli military intelligence, Lieutenant General Dalia Bakal Sapir. Unfortunately, there is no such woman, or fortunately for the algorithm, but unfortunately, this is a very high rank in the Israeli army. And she had this to say to the US. The United States would like to know what is the meaning of the money, as they are our biggest buyers, and what is the meaning to spend our money on Hamas rather than Hezbollah, Lieutenant General Bakal Sapir added. So maybe it's not completely coherent, but I think it's relevant, it's original, it maintains consistency on the topic and on the speaker. It's a very nice result, and with GPT-3 today, you can get convincing snippets that look like news, for example, in English. So this is on the text side, okay, actually we also already covered my view of creativity and ownership. So I hope I convinced you that, or maybe I should say it explicitly, I see these algorithms as tools that can empower the human, empower the artist, and I think the outcome is a hybrid, is a cooperation of man and a machine. Okay, so this is a slide that I took from Jan LeCun, and trying to summarize what we have and what we don't have. What we don't have is maybe more interesting for us. And he emphasizes that we are missing machines with common sense, intelligent personal assistants, smart chatbots, household robots, and something called artificial general intelligence, which I do not exactly know what it means, but this is maybe another conversation. And let's talk about deepfakes.
אזרחי ישראל, לילה טוב. אתם יודעים שחדשנות נורא חשובה לי. נכון שמעולם לא ניצחתי בפורטנייט, גם לא את החמאס, ונכון שלא הייתי בטינדר, בטח שלא...
So it's in Hebrew, so I'll spare it from you. And here we are moving on to the second part. I will give some introduction, and then we will go on to dirty our hands and be hands-on and hopefully participatory. Maybe it's a good time if there's to review if there are some questions up till now before I go into this new subject. Feel free to open your mic. Okay. So deepfakes. Here you see an example of a face swapping or face transplant, also known as deepfake. I took this guy from television and put on him the face of Benjamin Netanyahu, our prime minister, or one of our two prime ministers. And deepfakes are quite popular nowadays in media. Let me discern between two variants. The first one is what originally was referred to as deepfake or face swapping. And here I have Obama. He will be the driver of this, effect. And we have here the Chinese president. And he is so-called the victim. I just find this terminology better than source and target because it's less confusing. So here the victim's face is transplanted on the driver's face. So I have the driver office and body and hairstyle and just grab the face and transplant it. This is deepfake. This is a slide, by the way, by Yuval Nirkin, having a startup doing exactly this. The second one is called puppeteering face recognition.
Eyal, maybe small pause. Yuval, I actually talked to him this week about presenting here in this group. Yuval is working on a new research right now. If it comes out well, which we will know by July, then he will be presenting something new about fakes, but kind of new topic that he's been working on.
Thank you. There was a question by Brian about music generation. Actually, I didn't put it in the slides. but there are many works on music, both from the old days and of course contemporary work. And just a few weeks ago, there was this a jukebox, I think, from OpenAl showing very interesting results. And it also depends if this is conditional based on something else, or style transfer, or create just new music in a certain genre. So please try to search, and I can later add more references if you take it offline with me.
Yeah, also let me know. I have a couple of somewhere saved down, a couple of researchers late from this year in the same subject.
Okay, so the second type I want to consider is the puppeteering or face reenactment. And here the driver, the lady with the short hair, is controlling, like in a theater, like in a, I don't know, Muppet theater, she's controlling the victim with the long hair. So we retain the background and the body and the hairstyle of the victim, and the driver only controls the head pose, the expression.
Eyal, maybe, did you continue with the slides? We're still seeing the Benjamin Netanyahu.
Oh, yeah, I'm paused, so thank you for letting me know.
This is Shai letting us know, actually. He was the first one to notice.
Thank you. How do I unpause? Okay. I'll just reshare my screen. Forgive me for my Zoom difficulties. Okay, so you just, I guess we've just missed, just missed this slide. So this is deepfake. So this is the face of the Chinese president on top of Obama in Obama's office and Obama's body. And the other one is puppeteering or face reenactment. And here the short hair lady controls the victim long hair lady, so-called victim, just controlling her facial expression and lip sync and head pose, but retaining the background and the body and the hairstyle. And historically, this is considered more difficult, but actually we will see today we can do it quite easily. Okay. A few words on how this works, or how on the most simplistic level, how it worked in the beginning. And you already know about encoder-decoders and about the latent representation. So I can take my image, put it in an encoder, get the latent representation, again, the computer code representing the semantic knowledge from the image, and now use the decoder to reconstruct the given, the original image. So this is actually self-supervised. And I can do so also for Benjamin Netanyahu and many other people. But there is a trick. The encoder is universal. I'm using the same encoder for everybody, but the decoder is personal. So I have my decoder and Bibi has his own decoder. This is in training. And inference, there is a second trick. And I'm putting my face into the universal encoder, getting the encoding of my specific face, but using Bibi's decoder and getting someone with the likeness of Bibi, but taking, I'm not showing it in this specific image, but taking my facial expression and my head pose, etc. And in this way, I can control his face and do either a puppeteering or do either a face swapping. So this is a simplification of how deepfake works, or how it worked in the past. This is another example. It's not so interesting. This is a better example. The volume is low, but this guy is a very talented impressionist, a voice impressionist. And as he changes between these different celebrities or other actors, they transplant the corresponding face, and the effect is very convincing, especially if you can hear it, but the volume here is too low, so maybe you can check it out later. And there are algorithms also for faking voice, but still usually it would be more cost effective to get a good impressionist to do it. Okay, and of course, there are some known negative usage of this kind of technology. Here, going from the face is not changed, but they're actually trying to create a naked, a nude body based on their clothed body, and of course, without asking for their consent. So this was an app that was taken off the internet, hopefully. But going to the domain of the full body and recalling the task of generating video, and we spoke about video to video, so now I'm coming back to it. In this interesting work that is called Everybody Dance Now, they take an input video, the driver, the dancer. They go using pose detection to the skeleton, and from the skeleton, they recreate a video consistent from frame to frame of this student that wrote the paper. She doesn't know how to dance like this, but they're generating her video just from the video of the skeleton. Let me jump to the last example, which I like here. The ballerina. Ballerina can dance ballet, students cannot dance.
There's a question here on the chat.
Yeah, let me just mention, it looks choppy on Zoom, but if you download my 2 giga strong and you have to download it slides, you can get the better quality version. Yes, there was a question. How many pictures of the subject? That's a very good question, because I'm just going to discuss this. So there are a few teams developing these technology. One is getting better quality results, dealing with more modalities, combining more modalities. For example, face, a body, maybe voice, maybe various other conditions. But another trend is being able to use less data, being able to use not require a training or elaborate training for each new source and target, for each new, say, victim and driver, doing so in various modalities, and also allowing to make inference maybe in real time. So these are our bodies of works trying to do few shots, video to video, or few shots reenactments. And in a second, we will go to the case that we will discuss today, doing it with one shot. So just using one image for the target and say one video for the driver, not training on them, using a pre-trained model and applying to get inference in real time on your chosen source and target materials. And this is what we'll do in the tutorial now. And I see that my screen is paused, and I wonder how long it has been paused. So I guess from the Everybody Dance Now. So I'll just play this again. So after Everybody Dance Now, we discussed the few shots that you can see now, showing, again, different modalities, but using only one or a few examples. And so here they're doing it both on the body level, on the talking head level, and on the scene recreation level. And also in this next work, and there are also some new works going in the direction of one shot, and this is actually similar to what we will see now. Okay, so also people worked on audio, but I'm not an expert oh, sorry, I'm not an expert of this, so let me skip ahead. Today it's common to talk about the impacts together with technology, and I have the artistic and activist hat. So let me say a few words before we dive into creating deepfakes and how I view the subject from a moral point of view. We started a bit late, so I still have some few minutes for the hour-and-a-half strong talk, and then we will have the hands-on session very soon. So 3 positive aspects of deepfakes. 1, most importantly, I hope this will raise the accessibility, will raise awareness and skepticism. And what we're trying to do today is show how it can be made or how it is made more accessible. I think there are some Jews here. You know about blood libels from the distant past. We have some fake news example going back to the 1800s, where even some decades before this image, but also this image from 1898 of Herzl, which is like the Zionist visionary. And he met the Emperor of Germany, but the photographer was too confused and he didn't take a good image. So he did a photo montage and it ended up with this famous depiction of their meeting. Going forward, you know the examples where you take some image for some conflict zone, say Syria, and maybe someone else like the BBC says that it happened in Palestine. A little more difficult manipulation done recently was taking this image from the States, from this right-wing demonstration, and this guy, the Shadow, very bad person, he used Photoshop or some similar software to put the logo of B'Tselem, of a right-wing, left-wing human rights organization on the shirt of this right-wing guy to say that they are also neo-Nazi. And he let us believe that this was maybe taken actually in Israel. So manipulating images is accessible almost to everybody today. Videos is harder, I agree. But you know, the Disney, Hollywood, the governments, maybe NASA, I'm kidding, but they could do it for like decades now. And now it's becoming more accessible. And I think that this accessibility, I hope, will make people more aware of the possible possibilities today to generate and manipulate media, and people will be more critic of the media that they consume. I mentioned privacy infringement, and of course the very famous example from the early deepfake days of taking the face of an actress and transplanting it into porn. So this is Gal Gadot, Wonder Woman, in porn that she didn't play. And of course, this is a negative usage of the technology. I want to advocate that you can actually use it for doing privacy preserving media creation. In this example, the quality is not good, it's just conceptual. So I used a candid camera. I went on the street to talk to nice ladies, and I wanted to capture the reaction. And I couldn't do this for many years because I didn't want to go and ask for consent before or after. I didn't want to blur or pixelize the face. So I just couldn't do it. But now with the power of deepfake technology, I can take an actress, a consenting actress, and transplant her face on the subject. So I protect the identity, but I retain the authenticity of the reaction, the expression, the lip sync, the head pose. And I think this can open new genres like more realistic docu realities, for example. And the last point I want to make, I call it the fake anything paradox, which is also the title for this talk. And what the lesson I'm trying to learn here for myself is that my media representation, maybe even my physical representation, it's not me. And there was this example, some politician in some Muslim country, there was allegation that he is gay, had gay sex, or there was a video as such. And I don't know if it's true or not. He claimed it's a deep fake. I don't know if this is true or not, but I was very happy that he could claim that. In this example, you won't see me having sex, but here I am picking my nose. So actually we don't have time, so I'll skip the image. I'll just describe. On the left one, it's a video of picking my nose. And on the right one, Peter created a deep fake of my picking my nose. Now, Peter is an expert, and he made this very, very good deep fake. I'm very embarrassed about the real video, but I'm very satisfied and happy with this wonderful result Peter made of the fake video. And here's the paradox. These are actually, they look exactly the same. You cannot tell the difference if you see them. And it's a paradox, because if I feel negatively strong about this, but positively strong about this, and they look the same, there is a paradox here and something has to go. And I personally choose to give up my negative feelings and understand that in a world, at least online, that everything can be fake. You cannot know if it's real or fake. Maybe I shouldn't care so much if you see me picking my nose or having strange sex. Okay, so so with this, I conclude this frontal part of the talk. There are some slides here showing manipulations of faces. The context here I mentioned in the beginning. I just promised to say a few words about the mini residency that I host in the context of the newsletter Hashot. And now is the third class. In the first class, I worked with an artist, with a theater artist, Yosef Mashiach, and he is not a machine learning guy. He knew a little bit about programming, and in a short period, he was able to reproduce new variations using SPADE encoder on face manipulation, and do this in an interactive fashion in a real theater show. And in the second class, it's in Hebrew, so let me just describe. We work with Eden Azulai. We created, based on word embeddings, a generated poetry in Hebrew, which, as far as I've seen, is one of the best results, if I may say so, that I've seen, at least in Hebrew, for poetry generated without any prior patterns or human priors, just based on transversing the embedding space. Okay, so now I conclude this presentation. Don't worry about these links. Peter already shared them for the slides and some of the, I just mentioned that the generative tools, you can find many collabs that we'll see now, an example that you can play with these things online, and so on. So as I switch to my browser for the hands-on part, do you have any questions? Peter, can you monitor?
Yeah, I'm gonna explain now. So everybody who's staying here with us, this is a part where you get to work on your laptop or your computer and do deepfake yourself. In this part, we have to know that you are here with us. You know, especially Ayali, he's gonna be guiding you through this while you're doing the hands-on yourself. But we need to know that you are here taking part. So please, just everybody either introduce yourself just briefly via audio or on the text on the chat, so we know that you are going to take part in this, because otherwise it's a bit weird they are being here and nobody is really taking any part.
Yeah, Peter, I see we're like 40 people strong. Maybe we can just do like a quick gallery view of people saying hello and.
Yeah, we can. Everybody can just write on the even on the text. That's
yeah,
okay.
so
I see people already writing here.
So I do not want to police you opening your camera. Actually, I'm against that. And what I'll show now is a technique where you can maybe use later to participate in events without showing your face. If you do not want to, of course, if you do, please feel free to open camera and say hello. Thank you for those who are doing so. And maybe I'll take this a chance, and maybe Peter, you can spotlight my alter ego here.
Yeah, just 1 second. I see we had a couple of questions we missed. So Arthur said there are competitions on Kaggle for using AI to determine a deepfake versus a real video. Do you see something like that being used practically in the future, or would they just be another discriminator for the AI to compete on?
I'm not sure I got the end of the question. So of course it's like arming, if there's such an expression in English, race between the detector and the faker. And I don't want to go into the technicalities, but I want to raise one interesting point. What is fake? So of course we have this specific algorithm that you can find, but some manipulations are legitimate. And we can discuss it. Maybe if I have some zit on my face and I fix it, is it okay? If I fix the lightning, the brightness, is it okay? If I fix something in the background, so if it's a model, there's some criticism if they make her too slim. But maybe some of the manipulations are legitimate. And I'm not sure where to put the boundary line. But of course, it can be interesting to highlight the areas that were manipulated. But it's not necessarily, it's a spectrum. That's what I'm saying. When you manipulate images and start to put in fake content or some manipulation. Were there more questions? And could you, in the meantime, spotlight my alter ego?
Yeah, of course, yeah. Also, somebody asked, I'm going to mention it again. I've just pinned this one, I need to spotlight also. Yeah. So I just posted again all the links for all the places where you can find us, the newsletter, the YouTube channel, the Discord server, Reddit. The references also to everything Eyal showed you is on the Reddit. It's also there on the links. Anybody who's not seeing it, just let me know and we'll send it again.
Okay, so in this hands-on part, I will introduce the technology from the paper First Order Motion Model. We'll see it in a second. Just let me mention that in April came out Avatarify. It's a wrapper, very nice wrapper for this library, and it allows you, if you're somewhat tech savvy and you know how to do git clone, and you have a strong enough computer, or you know how to connect to cloud GPU, you can do this real-time, one-shot avatars and connect with them to Zoom. And get this very nice effect. And today we'll play with this offline because this is too resource intensive. But if you want, maybe later you could go and try to do also the Avatarify thing, which you would have to do some local installation. What we will do now, we will consider the offline thing, which is completely in the browser. By the way, this is the president of South Africa, and in 2nd July, I will give a 2-hour workshop just on this subject. And also, I got some like personal best practices relevant both for Avatarify and for the original First Order Motion Model, which I will share with you today. So stay tuned. Let me go back. Yeah.
What was the repo called from GitHub for this?
Yeah, so now I'll introduce it.
Okay.
This is Avatarify. Let me just I want to share my screen and sharing the chat. Oh, Peter, can you put in the chat the two bit.ly collab FOMM links? I know you have them. And in the meantime, as Peter puts it up, this is the paper on discussing first order motion model. And what's interesting is this is the one shot I discussed. This is Avatarify is based on this, and here they do like talking heads or full body manipulation without training on the new source and target using a pre-trained model, using only one image for the so-called victim, and allowing to do, as you've seen just now, do inference in real time. Now, from an artistic point of view, I think I won't have time to go into this now, but I use this to do very interesting for me online, because it came right in the right time in the Zoom days. So doing online artistic and activist interventions, if you want Zoom bombing. And what we'll see now is how you can create deepfakes based on this paper. So Peter shared with you the two collabs. It's bit.ly.
I'll share it. Yeah.
And there are two of them. And let me just mention that this is not my work. And the original author also put up a collab, and you can find other versions. What I did try to do here is make this completely and seamlessly accessible to the general public, and maybe hopefully to artists, activists, journalists. And if you're more tech savvy, you can also go in and play with various options. And I also added some of my personal best practice experience. There are two collabs. The first is based on the talking head model. If you don't know what a collab is, it's a notebook in the browser using Google GPU. So you would need your Gmail account, and once you open the link, it will say here where my cursor is, a copy to my Google Drive. You have to press that. It will open a new tab, and then you can go in and run and edit it. To run it, you can do a run all, but maybe more sensible for now to go for each box of code, just press play. I already did it, but you can go ahead and do it with me. And start with the given notebook, and then you can manipulate it. For example, later here, I will ask you to change the video or the image or both. There is also, this is with URLs from the internet. There is also a manual upload option. Please read the instructions about renaming and about being patient if you use the manual option. As you run it with me, and imagine I press play, there's an option here to make the video shorter if it's too long. And then you do prepare assets. And after a few seconds, you would see your assets. Here, young Benjamin Netanyahu is the driver, and Ahmed Tibi, a different politician, is the so-called victim here in my terminology. You then press play for getting best alignment. In a second, I'll see if there is any issues. This would show you the landmarks of the facial features and automatically find the best frame to start the effect from it. You would then press play for animate. There are some options here. I just added now exaggerate factor. It's my addition, and we can discuss it later. But leave it for now at the default, please. And finally, you have to scroll here inside the box, and you would see this effect. So just pressing play, run all, I get Bibi driving the video of Tibi. And there's a funny effect with the hand. Probably it actually works well with more frontal face, a cropped image and video. But you can play around and try to get different results, and you can then download. If it fails, download again, or open the folder on the left and manually, you can manually download your files. Okay, so please go ahead and run this on your browser after you do copy to your drive. After it works, feel free, please change the video and the image or one of them. And once you have results, we would love to see your screen, or you can upload it somewhere or share in the Discord. Maybe if you're more tech savvy, you were able already to connect with Avatarify, but if not, we don't have much time. We have like maybe, I don't know, 20 minutes or so. So, so please, let's stay with the collabs for now. And this is one option. Were there any issues that I can help with? Excuse me?
How to ask the question on the chat?
Yeah. I just wanted to mention that the Avatarify can also be combined with the StyleGAN face generation, and I can just go and generate these new completely generated faces and get this just nice avatar and these completely new people. So this is another
If someone is missing it, I almost missed it. You just need to look at Eyal's video now. You see that.
Sorry, yeah, you don't see. Okay, forget it. So this is a more remark about Avatarify. There are many options inside. But yeah, going to the chat, and hopefully you're now running it by yourselves. The resolution, well, I'm taking care of the resolution for you. It works both on input and output of 256 by 256. There were some attempts also to do resolution enhancing. I put the link in the beginning. It didn't work so good for me. By the way, in the top of the notebook, someone asked before, you can have all the links to the original paper and repository, to the original notebook, to other stuff that they did, and also to the Avatarify repository. This is one notebook. Another notebook I prepared for you, very similar, using two models from the paper that they did not put in the notebook, using doing this effect for full body, using either the Tai Chi or the fashion models. And here I'm also added some like automatic crop to the body, and there are various options. But in the end, I took this Kung Fu form and wanted to apply it to this model. And the results are not so good. The alignment is much more difficult. But I only did several attempts, and if you get better results, feel free to share. So you see, she also opened the legs like he did. And now some problems with the hands, but from time to time, you can see the fist going forward. And in a second also, he will take a side stance and she will follow and also put out her fists for a second like he does. So hopefully you can help me find maybe better examples for this. But this is another notebook. So you can, and maybe it takes a little bit longer. So maybe you would like to make the video, if it's a long video, make it shorter using the option to optionally shorten video. So I would like to stop talking now. I would love just to help you solve any problems or issues that you have, either with the code. Even if you have bad results, please share. Probably I can give advice on some practices to improve. And this is a hands-on participatory phase. And I think it's an opportunity to see, if you're not experienced, how to make this effect with no experience. And if you are experienced, please consider the effort done here to make this more accessible to people that do not have your knowledge. And I would also be happy to take remarks on this.
I would add, even for somebody who is, you know, has a bit of background in this collab you made is useful, even like for me to try stuff and to play out with. So
Yeah.
for the more technical background people here, I think this is good. I sent everybody, the links on the chat on Zoom. Just let us know if you don't have the links.
So hopefully everybody is running their own collab. Was someone successful running the original one? Can you say so in the chat?
I want to, in the meantime, show what I had earlier today with the full face, with full body swap.
Yeah.
Let's see how I can share. Now, let me turn this on. Where is it? And let's close this. So this is the video I put on YouTube last week about the blog post I did about pose estimation. And there are like 2 or 3 guys there on the video moving and jumping from a trampoline. And this is the result.
Okay.
It's kind of awesome, actually. It doesn't look like anything that makes sense, but it still looks very cool.
Yeah, so please note, these models work not so good as a talking head. They were trained on specific, very constrained Tai Chi videos or model videos. You can see examples in the data set in the project page from the original author. So it's not expected to work so good on other kinds of images or movements, but I think it's fun to play with. If you compare this to the Everybody Dance Now, their results are much better, but it's so difficult to get the code to work and you need to train it. I couldn't get it done myself with my spare time. But here, you can do it with a few clicks. It's not good enough for full body, but for talking heads, and maybe I think you can appreciate that after some poking and tweaking and experimenting, you can get pretty good results. And if you download the videos, you will get back a full video with the audio, which also helps to make the convincing effect. A question in the...
I think Alto has a question. By the way, Alto, feel free to talk if you are able. Just feel free.
Yeah, asking about adding source images. So in the collab, you can just change either the URL or manually upload the file, as I explained. And in Avatarify, you just put the images in the folder and you get all the images you want. It's very easy. So hopefully, so people said that they're able to run, and hopefully you are now experimenting with your own video and or image. And I would love to see some results. Either share your screen or share a link, please. By the way, you could also do this funny effect. If you have a video, you already know that you can put it in the background of Zoom. So if you create a deepfake of yourself, you can just put it as a virtual background and move out of the frame. Does anybody care to share some? Also, failed results can be funny, and maybe I can give some advice. So I think it's very educational also to share the negative results. So does anybody have any issues or questions or results? So let me say that for me, this came in a very good time. Everything moved to Zoom. As I mentioned before, I didn't want everybody to see my face. And I started to think, how can I participate, but also be someone else? And if you remember Ready Player One, the book, the film, they promised us for a long time that one day we will have this cybernetic utopia and we can be whoever we want in virtual reality. Now, there are meetings in virtual reality, but they're not very common enough. Most of the meetings are in Zoom, and you see all these faces or black boxes in the gallery view. And maybe it's more boring, and for me, the question was how I can fulfill the promise of cybernetic utopia in Zoom. And just a few days before Avatarify came out, so I was very happy to find this. And do I see? I got one. Doesn't look great, but definitely funny. Please, author, please share your screen. Please show us. So I guess this is the talking head model, right, author? So I guess what's
same video.
So I guess what's happening here is that the talking head model is trained on a head, not a full body. Sometimes it works, sometimes not. To get better results, you probably should crop the image. The face should take a considerable part of the image. I didn't want to force it because I wanted to allow people to play with it, but you would get better results. And also, if you make sure the alignment between the driving image and the target image, specifically the location of the mount, then you can get better results. Does anybody else care to share with us? Oh, very nice. So here, I'm not sure how to say your name, but very nice result trying to do a cartoon. Now you may notice that the Homer Simpson is not opening his mouth. Of course, it was not trained on this. The effect is very nice. The first order motion model actually does inpainting, and if there is an occlusion or a closed mouth that is now open, you will sometimes see teeth generated. But for Muppets or for cartoons, it doesn't know how to do so. And in order to make it try harder, I introduced the slider, which I call the exaggerate factor. And maybe you would like to play with the slider, change it maybe to 2.5, and see if it helps to force Homer to make more motion in the area of the mouth by exaggerating the movement of the driving key points. So this is the slider that I added called exaggerate factor. I just added it before this talk. Thank you for sharing. Anyone else? Okay, Shai. Okay, very nice. Probably if you put in the audio, which we cannot hear, it will be more convincing. Also, as you might have noticed, just moving around a bit, even if it's less realistic, can help get a sense of a livelihood. So for example, if you don't see my screen, but in a second, I'll show it. So here I have this Muppet, and I don't control it so much, but if I just go like this, it looks more livelihood. I try to open the mouth, doesn't work so good. Let me increase the exaggerate factor. So there's some warping here, but I have now a slight control on the mouth. Maybe too warped, but this was my attempt, easy attempt to fix this. Okay, some more results, please. Or any other questions or issues? So thank you for participating. I'm going to give a full workshop on this in 2nd of July. and probably in other occasions, and maybe even in Peter's group if people are interested. If you have any later questions or remarks, results, please share. Please feel free to contact. And hopefully, if you're interested in working on this, I'm very much interested in making this more accessible. I'm trying to do the real thing, avatarify thing in the browser, in the Colab. People are trying, but it's more difficult. We can get maybe 1 frame per second, which is not good enough. But stay tuned, probably in some time it will be possible. And as an artist and activist, I'm trying to use this for my own stuff, and hopefully you can find the relevant applications for this. And
I also have a couple
for participating.
Everybody just wait like 2 more minutes after I have also a couple of words. First of all, Eyal, we didn't plan this, but I'm gonna say to the group here, if there is interest in a workshop for Avatarify, something a bit more hands-on even, let us know. Discord, on Reddit, on email, however you can. And you know, like it started, this group started with me posting, if there's 20 plus people interested, we'll do it. Most probably, if there will be 20 plus people interested here, we will do the workshop again. Just let us know. Eyal, thank you really so much. This is one of the coolest Zoom sessions I was ever on personally. It's so fun, thank you. And for everybody, so I think it's a month that we are live. The group exists, the 2D, 3D AI group, and there's in total about 700 people registered. Maybe today it's even more. This is crazy, so awesome. And this is, again, this is why I personally decided to invest more energy into this and to bring more content with interesting speakers like Eyal. I will be actively searching for more speakers to join and to present for our group. If anybody knows of somebody who is interested in presenting, who works in these fields, please connect him to me in some way and we will make this happen. Having you here, having this group working and engaged, that's the helpful thing also for me, for my own excitement on doing this, and also to convince, you know, high-ranked people or people who have a lot of other people interested in their work come to us and talk to us because they see that there is an engaged audience with them. This is, I think, also one of the reasons why we could have Eyal here. I sent out, I'm gonna send again, the Google form for your feedback. Please fill it out. This is important for me to understand how to manage this thing and what to do more. I have a couple more ideas I'm considering, so it's all in the feedback form. If you have any more ideas for stuff that we can do online, be it live or offline, kind of like not live, online sessions, just let me know. I'm really curious to hear your thoughts. What else? So the links I've sent, if anybody doesn't have them, just tell me and I'll send again, but I think I've sent them several times, so you all have them. I see already which Discord group? Okay, so I'm gonna send, again, I'm gonna send all the links so you will have. 1 second. Oh, there's so much chat here we had, wow, that's so good. Yeah, a lot of people said thanks, I'm just saying.
Thank you.
So this is the bulk of all the links. So you have the Discord is inside of here. It's the Discord server for instant messaging. This is like WhatsApp or Slack if you're familiar. So we're using this for everybody to communicate and to get to know each other and have even personal communication if you're interested. I think I only sent it to one person. I'm gonna send it to everyone now. So now everyone should have. I'm also gonna again send the newsletter link so you all have it for more updates, including this lecture. I'll upload it to YouTube, the channel you see on the links I just sent, and I will update on the newsletter once it's uploaded. I will also update on Discord and I will update on Reddit so you could all see it. Let's see if there's other questions.
I think
so-
Rachel or Rachel wanted to share something.
I see actually a couple more questions. So go ahead. Anybody who has questions, it's a good time to ask. We're not finishing yet, so you can ask the questions. Rachel, if you're still here, feel free. I think I saw also, I saw somebody, but now I don't see the text. This is why it's comfortable when people talk. Oh, I think Andre asked, after this, Eyal, Andre has a question about Avatarify.
Ah, very nice.
Yeah.
Try to play with the exaggerate factor. I would be interested to see if you can make the cat show some teeth. Could be interesting. Let's see the question, and everybody also feel free to share your screen in the meantime. I'm not sure what the question is. Peter, can you point me out? Or
I'll say just, Andre asks, in general, bird's eye view, how you can connect your live talking head to Zoom?
So the question is how to connect this to Zoom. So if you're doing an offline video, you can just go in and change the virtual background. Can you stop sharing your screen, please, Rachel or Rachel? Or Peter, can you?
Yeah, I'm trying to find out. I hear stop participants sharing. There we go.
So as you see in my background, or for example, you can put your friend.
Thank you for this again. This is everybody, you just need to understand this happens every call we have, really. I've actually sent it to friends, you know. Yeah, I didn't tell you, I have a friend who used your tutorial to do this thing. And then I sent him this video and he's like, oh my God, I can't believe it. Is it real? And he's like, how good is it? And I said, it's so good, it got me confused the first time.
So you can just put your video for the time in a loop. The way to go forward is using Avatarify. Unfortunately, this is a little bit more involved and you need to do some local installation. There is an option to use a remote GPU. And maybe if you're a little bit tech savvy and you're not afraid from the command line, you could go on the instructions in Avatarify and set it up. Please try. It's very, very nice. And then they explain how to connect to Zoom. You can use on Linux, they actually implemented it. On Windows, you can use software like vMix or OBS and create a virtual camera from the Avatarify window and put this as any other camera inside Zoom or Facebook Live or anything else. You may have some issues on Mac, but I don't know anything about Mac. Going forward, as I mentioned, people are trying to make this work completely in Colab. It's somewhat of a hack because there's no real-time webcam processing currently in Colab. I'm also trying. I couldn't get it done. If you know anything about WebRTC, please contact me and maybe we can do it together.
Yes, so unless anybody has the questions, really feel free still to ask. I think we're almost wrapping up. So I've sent you all the links to everything. Again, please fill out the form, the Google form for feedback. Yeah, again, really, thank you. This is so cool. We have still, how many? 20 people still left. This is 2.5 hours. This is, you need to understand, Zoom events don't happen like this. I've participated in many. Having people stay so much for so long, this is a very beautiful sign that this content is relevant and interesting. And this is, I think, for Eyal and for me also, this is like a, I don't know how to say it in English though, I think. It's like, it makes us feel appreciated in a way. So thank you again. Yeah. And again, if there is interest in more Eyal speaking, just let us know. If there's enough people, I'll bring him on again. No worries. We'll have him. We'll catch him on. So
come to one Viners talk. Yeah.
Good mention, Eyal. Yeah. So in a couple of weeks, Ron will be talking. He's also a good friend of ours. Ron is also running the foundation called Give and Tech, where him and us and other teachers are teaching people machine learning, and all proceeds from the students, they go for charity. So Ron will be talking in 2 or 3 weeks about the origins of machine learning and introduction to machine learning, so really come. It's already on the meetup and on Reddit. I'm gonna publish it on the newsletter and on Discord and the following week, so we will have this.